and to better equip those of you who are developing advanced AI in your own organizations. A little bit about me. I'm Angie Lal. I lead the security engineering team that works on protecting production critical assets at Anthropic. Anthropic is an AI safety company where we're working to build reliable, interpretable, and steerable AI systems through our research and commercialization efforts. And prior to Anthropic, I was most recently at Stripe for nearly 9 years, where I helped to build, scale, and manage security teams. So before diving in, I'd like to give a quick overview of Anthropic's perspective to better frame the conversation. I'm not going to discuss Anthropic's AI, which is called Claude, in this talk, except to briefly mention it here, so you all have a better understanding of who I'm representing and what perspective we're bringing. There are 3 frontier AI labs right now, though there may soon be more: OpenAI, DeepMind, and our company, Anthropic. And Anthropic is incorporated as a public benefit corporation, which means that we can optimize for our mission over our shareholder value. And we have also developed a new corporate governance structure called the Long-Term Benefit Trust. That, paired with our PBC status, aligns with our corporate governance with our mission of developing and maintaining advanced AI for the long-term benefit of humanity. And Anthropic, with 6 other companies, signed on to the voluntary White House commitments for AI safety in July and have been in the front of the US Senate twice in the last few months, and are also participating in the UK's AI Safety Summit that kicked off yesterday. We're a small company on the order of a few hundred folks, but we're laser focused on safety, and we publish our research on the topic pretty extensively. I very much want to acknowledge that this is an emerging technology where there are many unknown unknowns, and we certainly do not claim to have all the answers here. Though I am optimistic that we as security professionals here can all collectively contribute to developing this knowledge base and finding solutions. So this is a quick preview of the main areas we'll be focused on today. We'll talk through some of the primary risks that frontier AI presents, then discuss a particularly effective security control to mitigate some of this risk called multi-party authorization. And lastly, we'll briefly touch upon improving security and compliance standards and enabling greater cooperation across sectors and how that can play a role in securing advanced AI. So before discussing the key threats, let's first define what frontier models are. Frontier models refer to general purpose AI models that are at the cutting edge of capabilities. These are the largest, most complex, most powerful AI models developed to date, such as those underlying ChatGPT, Claude, and Bard. So this chart from Our World in Data zooms into the last 2 decades of AI development. Researchers compared human and AI abilities across 5 areas: handwriting recognition, speech recognition, image recognition, reading comprehension, and understanding language. Human ability was set as a baseline at 0 points. And initially, AI scored negative 100 points compared to humans. And as you can see, AI systems have improved over time, and their scores have crossed from negative into positive territory, meaning that the AI outperformed humans on that particular test. A decade ago, even the most advanced AI could not match human skills, but thanks to better algorithms, larger data sets, and increased computing power, AI capabilities have advanced dramatically. And while these models have the potential to create transformative economic and social value, they also come with major risks. Now, this isn't an exhaustive list, but hopefully this will paint a picture of what could potentially happen if these models were to get in the hands of unaligned actors and/or were not sufficiently regulated. Examples of societal harms could be AI hallucinating dangerous information, inadvertently radicalizing individuals and nudging users towards harmful actions as an unintended consequence of the model design. Other examples could be disruption and displacement in labor markets, or amplification of biases that are in the training data. In terms of misuse, we could see the development of biological or chemical weapons, especially as advances in the life sciences accelerate. And on the cyber front, we might see increases in the scale and speed of attacks. And lastly, for loss of control, it's possible that AI systems may actively seek to increase their own influence and reduce human control, or humans might decide to increasingly hand over control to misaligned AI systems. This is just all to say that securing AI systems cannot be an afterthought and must be a priority. As AI capabilities advance, so too does their potential to help or harm humanity. All right, so with that bit of doomerism out of the way, I'm here to share that there are things that we as security professionals can do to reduce the likelihood of these models being exfiltrated and getting into the hands of APTs and other unaligned actors. So to make this more concrete, I'll walk through how an APT might gain a foothold into AI systems. The most likely vector would be through some form of spear phishing that's targeted at the social network of an employee at a frontier AI lab, which through a series of compromises would then allow the attacker to successfully exploit the hardware of that employee. And once they have that foothold, they will move laterally and attack the production infrastructure, namely by using that employee's credentials to exfiltrate things such as model weights. On the other hand, models or model weights might be compromised through an insider threat, meaning an employee, for example, could use their authorized access or understanding of an organization to harm it, either intentionally, like through espionage, or unintentionally through negligence. So, how do we protect against this? Well, as part of our strategy at Anthropic, we're taking a layered risk reduction approach where we use layers of defense to block threats and mitigate damage. For example, the principles of least privilege and zero trust are heavily baked into our approach. This means limiting data and model access to the bare minimum, compartmentalizing permissions and credentials by role, and making threat actors move laterally through multiple hardened checkpoints. So in the case of insider threats, much of the risk is mitigated by implementing least privilege and role-based access controls. However, a major component of our risk reduction strategy, and the one that I'd like to focus on today, is the use of multi-party authorization. This is one of the most effective cybersecurity best practices that's used across many major tech companies to defend against advanced threat actors like APTs and to mitigate insider risk. And the most illustrative example of multi-party authorization is where two people with two keys are needed to open a secure vault. Now, if we were to extend this pattern of needing multiple parties to authorize access to AI critical infrastructure, we will have substantially increased the cost of an attack. So let me concretize that a bit. Multi-party control substantially reduces the risk of unintentional insider threats and somewhat reduces the risk of intentional insider threats by requiring now an explicit approval. For laptop theft or takeover, let's say due to a supply chain attack, multi-party authorization would introduce a checkpoint at which the user's security key must be touched in order to proceed, which mitigates considerable risk. The requirement for approval from a second party further reduces this risk in the case where the security key is also compromised or bypassed by now requiring laptop access as well as knowledge of who can approve the request and what a plausible request might look like. So let me walk you through what an MVP multi-party auth design may look like at a high level. So let's say a researcher wants to access model weights for one of their common workflows. They would go to the multi-party auth app, request the role needed, and provide a business justification for needing this access. And this would all be logged and audited. That request would then get sent to Google App Engine, which would direct the request to the identity-aware proxy, which then authenticates the user, sends back the access token to the App Engine, which would then post an approval request to Slack. Now, the approver would either need to approve or deny the request. The result would then get sent back to the App Engine, and assuming it was approved, an IAM binding created would come about, and the result would be passed on to the user in Slack. And it's important to note that before designing this system, we came up with a set of project principles that we wanted to be true. And one of the principles was to minimize workflow disruption. And we acknowledge that introducing a change like this one would introduce friction. One way we're trying to reduce major productivity loss is by working closely with research engineers to build a comprehensive understanding of the systems in play and to thoroughly test our approach before rolling this out more broadly. We've done a few smaller rollouts with beta users and have incorporated that feedback into our process. So as you may be able to glean, getting a simplified version of multi-party auth up and running is possible to implement, even for emerging AI labs without large enterprise resources. Though I do want to stress that it is non-trivial to implement this design correctly to avoid further loopholes. But given the benefits of such a control, we believe that this pattern should be applied to all systems involved in the development, training, hosting, and deployment of frontier models. On the next two topics that I'm going to be briefly chatting about, I'm happy to announce that many of these recommendations have been incorporated into the White House Executive Order on AI that was released on Monday. So just as multi-party authentication is considered a cybersecurity best practice, so are the secure software development practices found in the NIST Secure Software Development Framework, or SSDF, and supply chain levels for software artifacts, or otherwise known as SALSA. So for those who are unfamiliar, SSDF outlines best practices for secure software development, and SALSA provides a security framework on verifying provenance of software artifacts across the supply chain. And interestingly, since developing and deploying AI models mirrors software development, SSDF and SALSA represent a blueprint for instituting security. So applying SSDF and SALSA means AI systems can be traced back to their developers, establishing a verified chain of custody, which would provide accountability and auditability for AI systems. And lastly, governments have successfully used procurement requirements in the past to drive adoption of cybersecurity standards by tech companies before broader regulation was in place. So we believe a similar approach can also help to establish secure model development standards. So just as executive orders have been successfully leveraged to encourage major tech companies to adopt higher development standards, public-private partnerships could aid in ensuring that there are sufficient guardrails in place. It's important that we build a shared understanding of the risks and that we are equipped to coordinate effectively on preventing and mitigating them as best as possible, and that we continue to work together on frontier AI security. In the same way, critical infrastructure sectors like financial services have teamed up in public-private cooperation, AI labs could follow a similar model and work towards greater cooperation and information sharing between and among industry labs and government agencies. This would really help us all better understand and guard against highly resourced cyber actors. So to quickly recap our discussion, Advanced AI models have immense potential, but also pose economic and national security risks if not properly secured. As this technology approaches infrastructure level importance, frontier AI research, models, and model weights will likely require safeguarding beyond standard industry practices. We will need to evolve our security protections and continue to share our perspectives on responsibly developing AI. In the near term, we should leverage best practices in cybersecurity like multi-party authorization, extend software security standards to frontier model development and deployment, and have governments and companies commit to forming close public-private partnerships. As an AI company on the frontier, Anthropic is committed to building and deploying our models thoughtfully and securely, and we hope other frontier labs will also responsibly nurture this incredible potential that comes with building advanced AI. So if building safe and secure AGI speaks to you in any way, please check out our careers page at anthropic.com/careers. We're hiring across the company, and in particular, we have IT, security, and security TPM roles that we'd love to have you fill. So with that, I will turn it over to you all for your questions. Let's see. All right, so I see one in the chat. Do you have to do that every time you want to log into the app? So I'm assuming you're asking if you would have to request approval every time you want to, let's say, access model weights. So you do not. There is like a certain time period where you would have access to it. So you wouldn't have to do it on every request. So you might have it for, let's say, I don't know, 8 hours at a time before that permission would expire. Are there any other questions? All right. Well, in that case, thank you all so much for attending. I really appreciate it and would love any feedback you might have. Thank you. Take care.